Hi everyone, today we're looking at logarithmic functions. As you see, I put up a rule. It states that a to the power of n is equal to n. This is called anti-logarithm. And a, which stands for the base, and lowercase n, which stands for exponent. Okay, so what does the rule mean? So basically, a to the power of n is equal to n, which in log form is written as log a n is equal to n, which can be read as, so for example, we have log 8, which is not how you say it, but it's said as the logarithm of 8 to the base 2. That's how you say it. Okay, so now let's get into some examples. Okay, so first of all, let's say we have 2 to the power of 4 is equal to 16. Okay, so that's in our exponential form. So now we have to change it to our log form. So by doing this, we follow our formula. So that's in our exponential form, and that's in our log form. So what does our formula tell us to do? So first of all, we have to take out log, and then it says take out our base and put it here. So our base in this case is 2, and then capital N, which is in this case 16, so we take out 16 and put it here, and what it's equal to is our exponent, so which is 4. So that is how you write a log. Okay, so now let's do 5 to the power of 3 is equal to 125. Okay, so first of all, we take out log, and then second of all, we take out our base, which is 5, and then so next step is to take out our anti-logarithm, which in this case is 125, and what it's equal to is our exponent, which is 3. So it's read as the logarithm of 125 to the base of 3. Okay, so now let's move on to a harder question. So let's do 5 to the power of half is equal to square root 5. Okay, you can look at my previous video on exponential functions and laws, so you'll have a better understanding with the fractional exponents. Okay, so log 5 square root 5 is equal to half. Okay, so the logarithm of square root 5 to the base of, let's say, it was 5. Okay, so now let's do the reverse. Okay, so say we have our log, so log 3, 9 is equal to 2. So now let's change it to our exponent, exponential form. So first of all, it's read as 3 to the power of 2 is equal to 9. So 3 to the power of 2 is equal to 9. Okay, so now let's do log 5, 1 is equal to 0. Okay, so it's read as, so following the formula, so the reverse, in this case, we take out a, which is our base, so we take out a, so in this case it's 5, and then our next step tells us to take out capital N, which is 0, so we take out 0 and put it as our exponent, and what it's equal to, n, lowercase n, which is 1. So that's how you solve a logarithmic function. A logarithm equation. Okay, so now let's do log 10, and then 0.001 is equal to minus 3. Okay, first of all, so our first step tells us to take out our base. So in this case it's 10. Our base is 10. Okay, so second of all, we take out our exponent. So 0.00, oh wait, sorry. We take out, oh no, I was looking at the capital N. So we take out our lowercase n, which is minus 3, and then we take out our lowercase n, which is our exponent. So in this case, 0.001. So now you can see it states that 10 to the power of minus 3 is 0.001. Okay. So now let's move on to some equations. So now we have to find the value of x. So we have log 2 8 is equal to x. Okay, so we have to find the exponent. So the missing exponent. So first of all, so we're in this form, so we have to take the reverse, so we have to find this form. So first of all, we take out our base, so base, which is 2, so it's equal to, we write it down here, so 2, okay, so we take out 2, and then we take out the missing value, which is x, so to the power of x, as it states over here, so a to the power of n, so a to the power of n, and then it's equal to capital N, which is in this case, capital N is 8, as it shows over here. Okay, so the next step, so now we have to change 8 into an exponential form. So by doing this, we're going to write it as 2 to the power of 3. So the next step, so we compare, so we're going to compare the exponents. So when we look at this, so we look at 3, so that's our answer. So x is equal to 3. So we found our missing value, so log 2 8 is equal to 3. That means so that means 2 to the power of 3 is equal to 8. Okay, so now let's move on to some more challenging questions. Okay, so now let's do log 10 is equal to x. Okay, first of all, our first step tells us to take out our base. So in this case, our base is 10, and then we put up x, which is our lowercase n, which is our exponent. Okay, so 10x is equal to 10, which is our last one, which is our anti-logarithm, which is the capital N. So 10x is equal to 10. So we know that x is equal to 1, because 10 to the power of 1, so that is our answer. So and when you insert 1 into x, so when you go 10 to the power of 1, it satisfies our equation. So 10 to the power of 1 is 10, which means our logarithm is right. Our exponent satisfies our logarithm. Okay, so now let's move on to log 1 is equal to x. First of all, so we take out 4, which is our base, and then x, which is our exponent, and then 1, which is our anti-logarithm, which is the capital N. So we have 4x is equal to 1. So in this case, x equals 0, because anything, so for us to get from 4 to 1, we need to put 0, because anything to the power of 0 gives us 1. That means if you put 4 to the power of 0, it's 1. When you put 3 to the power of 0, it's 1, and so on. Okay. Thank you for watching, guys. So hopefully you enjoyed this video on logarithmic equations and functions, and exponential functions as well. And bye.